This is the fourth video on balancing reactions, so you can go ahead and pause the video right now and review some general guidelines on balancing reactions. So here we have a more difficult balancing problem that has to do with the combustion of a hydrocarbon. So we're going to first off take inventory like always. So I have 7 carbon on my reactant side, I have 6 hydrogen, and I have 4 oxygen. On my product side, I have 1 carbon, 2 hydrogen, and 3 oxygen. So recall, whenever I have something alone, I'm going to do it last. So in this case, I have oxygen all alone. I'm going to do it last because whatever coefficient I put in front of the O2 will only change my oxygen. So I'm going to start off with 7 carbons on my reactant side. I'm going to put a 7 in front of my CO2. So I now have 7 carbons on my product side. I have 6 hydrogens on my reactant side, so I'm going to put a 3 in front of H2. So now I have 6 hydrogens on my product side. So count your oxygens up now on your product side. I have 3 oxygens plus 7 times 2 is 14 oxygens, totaling 17 oxygens. Now, on my reactant side, this is where it gets a little tricky. If you notice, in your hydrocarbon, you already have 2 oxygens. So total, you need 15 right here. So you know whatever coefficient you put in front of O2, when you multiply it by 2, it has to equal 15. And this brings us to our next trick. Whenever you have a situation like this, you can use halves. So here, something times 2 equals 15. Well, that something is 7.5. So 7.5 times 2 is 15 plus 2 is now 17 oxygens on your reactant side. So total, you can see that you have the correct number of carbons, 7 and 7, correct number of hydrogens, 6 and 6, check, and the correct number of oxygens, 17 and 17. The only issue now is we need to get rid of this half because we need our coefficients to all be whole numbers. So the way I can get rid of a half is multiplying the entire reaction by 2. So if I have this 1 in front of C7H6O2, if I multiply everything by 2, this 1 becomes a 2. The 17.5 becomes a 15. The 3 becomes a 6. The 7 becomes a 14. So your final reaction, balanced reaction, would look like this. So here, our molar ratio would be a 2 to 15 to 6 to 14. So again, 2 to 15 to 6 to 14.